Um, 48. A farming cooperative mixes 2 brands of cattle feed. Brand X costs $25 per bag and contains 2 units of nutritional element A, 2 units of element B, and 2 units of element C. Brand Y costs $20 per bag and contains 1 unit of nutritional element A, 9 units of element B, and 3 units of element C. The minimum requirements for A, B, and C are 12, 36, and 24, respectively. Find out the number of bags of each brand that should be mixed in order to minimize the cost per bag. And then what is the minimum cost per bag? And, you know, there's a whole lot of people told me as I'm going around, oh, I didn't know how to set that up. But how is that different from example 6, which is the liquid portion of a diet is to contain, and it gives you now it's in terms of calories, vitamin A, and vitamin C, right? And it tells us the cost per, it's really the same problem. I mean, it should not have been a, oh my gosh, never seen anything like this before. It's pretty close to what we did in the example. Okay, so again, the first part of this is define your variables. And they tell us at the end what we're trying to figure out, the number of bags of each one. We have to make a mix, right? There's our X, there's our Y. They've told us the cost per bag. So there's our cost objective function, which we're going to try to minimize. Minimize costs, maximize profits, right? So 25 times X plus 20 times Y. I think I'm losing my laser. It's going to die. Okay. The constraints are, and pretty much like we went through, you know, for the vitamins and all that kind of stuff. The brand X has 2 units of nutritional element A. Brand Y has 1 unit of A, and the minimum requirement is 12. So 2X plus Y is greater than or equal to 12. Yeah?
Are those three, the brands are like the A, B, and C stuff?
They're the A, B, and C stuff.
So the first one is A and the second one?
Yes. Okay. The cost is in the top. So these are the constraints. No. I mean, this is coming from brand X. This is coming from the brand Y. Right? But these are constraints on the nutrition. I mean, otherwise, again, if you wanted to minimize cost, let's just give everybody 0. Right? Why not? Because we have some minimum requirements we've got to meet. Right? That's what the constraints are doing. They're telling you can't just do anything here. Okay. So this was, if you put together the numbers they gave us for the element A, it would be 2X plus Y greater than or equal to 12. This is for element B, 2X plus 9Y is greater than or equal to 36. Element C, still got X and Y greater than or equal to 0. Again, if you go back and compare this to what we did in class, this should not be a stretch. If it is a stretch, there's a problem. Okay, it's almost a one-for-one substitution. Right. So once you've got your constraints, graph them. Right. And I just did this with the intercepts. Right. X is 6, Y is 12. That is this line. X is 18, Y is 4. That's this line. X is 12, Y is 8. That's this line. And every one of those is shaded on the non-origin side because they're greater than, right? 0 greater than 12. No. It's the other side. So where does all the shading come together, right? It's to the right of the y-axis. It's to the right of the blue line. It's above and to the right of the purple line. It's above the red line. It's above the x-axis. So where are all of our vertices? Here, 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 and here. Those are the 4 vertices. And again, the way I did defined these 2, the others are easy to find, right? We knew those already. But the way to find those 2, and using the different colored lines helps a little bit, right? I know that this is the intersection of the blue and the purple. That's this one and this one. So in terms of matrices, that'll be 2, 1, 2, 3. That's the A. And 12, 24. That's the B. A to the minus 1B, and you'll get the 3, 6 right away. Right? This point is the intersection of purple and red. out of those two lines. So the matrix is 2, 9, 2, 3, and the B is 36, 24. A to the minus 1B, 9, 2. And I think I can just squeeze this in. No, let me stop.